Okay, here is a question about annuities. But before we go here, maybe we should do a little bit of a recap on what we've been looking at so far. We looked before and saw what an annuity is, series of equal payments at regular intervals. And these terminologies here, you've come across them before, so you're quite familiar with them. Now, then you saw the categories that annuities can fall into. About this, uh, you can have ordinary simple annuity. The order of words is not really significant. So ordinary simple annuity, the CY and PY are the same. And ordinary general annuity, CY and PY are not the same. But these annuities are ordinary because the payments are made at the end of the payment period. So at the end of a month or end of a quarter or whatever else there is. And these ones, annuities due, are the ones where payments are made at the beginning. So beginning of the month, beginning of the year, etc. And similar classification, it's simple. If CY is equal to PY, that means the compounding frequency is the same as the payment frequency. And it's general if the compounding frequency and the payment frequencies are not equal. All right, so let's go back now and look at this question here. I will copy it and paste it into the Word document so we can maybe see it a little bit clearer and maybe do some more analysis. So if you are following these sequences of questions in the quizzes, you can look at it as this is the one. All right, so there we are. And if we wish, we could decide to change the font and go with a different one, making the size a little bit different. All right, so let's go. So what we need to look at is the deposit. So there's the deposit, $206. So if we look at that, and that would be the payment. All right. So the payment is equal to, and we can put it in as negative because the money is going out. All right. So you may want to use a negative value if you so wish. That is your choice, but it's recommended. So at the end, deposits are made at the end of every 3 months. So for that part, we will have what? Well, we will have the PY value is equal to 4 times per year, end of every 3 months. Correct? So there we are. And that is another, another useful value that we need. All right, it's earning 1.6%. So that 1.6 is the interest rate. So we can put that in as IY, which is correct. That would be the IY value. All right, and then following that, we have the compounding. It's compounded semi-annually. Okay, so that means that we are looking at what? Well, we are looking at the compounding, so that would be the CY value, and the CY value would be equal to 2, right? Because it's semi-annual. Okay, so we have bits of information that are important for us, and so with that, we can do some calculations. All right, so if we go back, we can go back now to the previous document. Now, the 2 years is also important, 2 years and 6 months, because that will determine the value for N. Remember? So with that, this was mainly to give you some information about what is CY, what is CY, how to get to N, and these kinds of information, how to analyze what we're given. Okay, so let's go back here to the question, and we will see how we can do it on the calculator, right? So here we are. And if we were to fill in these boxes, remember the deposits are the end of every 3 months. So this would be PY would be 4 times per year. And the compounding is done semi-annually. Okay, so if that is semi-annually, then CY would be equal to 2. All right, with that information, we can go now to the calculator and we can put in some information in here. And there we are. So PY is 4. Let's put the 4 in. So 4, enter. And CY is not 4, but CY is 2. So therefore, we have to go click on 2, click on enter, and there we have CY. Now we can check these values. There's CY and there's PY. So we know that PY is 4 and CY is 2. All right, now we can get out of here. We could, seeing we're right up here, we can just hit the second and CPT and we will be out of that menu. Now we are going to use this 2 years and 6 months to calculate the value for N. Remember, N is the number of years times the PY value, meaning a number of compounding periods for that specific term of investment, meaning in this case 2 years and 6 months. So we should do a slight conversion first. Maybe if we go to, if you want to convert 2 years and 6 months, so 2 years and 6 months, right? So we can do the conversion by doing what? Well, we could take the 6 divided by 12, and that would make it years. And then we add 2, then we should get something like probably 2.5. Let's try it on the calculator. So we go 6 divide by 12, then we add 2, and we get 2.50. Okay, so that's 2.50 years. Okay, so with that, we can now go back to the question and use the calculator. We put in the 2.5 and we go second N and get the 10, and we click on N once more to insert the value for N, which in this case is 10. All right, now what is the interest rate? Well, the interest rate is right up here, that's 1.6. If we wish, we could just copy and paste it in there. All right, the present value is 0 because there's nothing there to start. And then the contributions begin the deposit of $206 at the end of every 3 months. So because it's being, it's leaving the possession of the person who is depositing it, then its money is going out. So we can put that in as a negative 206, right? And there we are. Now the future value is what we'd like to compute. So it says find the accumulated value. So if we put just temporarily, we put CPT in there. Yes, there's some red lettering, but don't be concerned about that. That is not an issue. All right, so let us now go to the next item to insert, which is the 1.6. The 1.6, and then that is IY. Present value, yes, we put in our 0. The 0 for the present value. Payment is negative 206, so we go 206. We hit plus minus, make it negative, and then we click on payment. All right, so now we will compute the future value, and we compute it, and we get a number. That number turns out to be 2,097. Okay, let's come in here, $2,097.40. All right, so we have the future value. Now we want the interest earned. Well, the interest earned is what? Well, let's go and let's put on something so we can understand what it is. So the interest earned would be equal to what? Well, it's the future value the amount of money, the accumulated minus the total deposited. Okay, total deposited. So that's equal to, well, we can find the future value, of course. It's not a problem to do that. And it's the value we just computed, and then the total deposited would be equal to, you have to take the payment, each payment, and multiply that by the number of payments. All right, so now what do we have? Well, we had a future value of, what is it? Let's bring up the calculator. Maybe we can still see it there. Yeah, $2,097.40. $2,097.40. Right? And we subtract. So what do we subtract? Well, the payment is 206 and the value for n is n. Okay, so 206 times 10, we can do that easily. 206 times, sorry, way down at the bottom. So let's get back up there, times 10. So we will get what? 2097.40 minus 2060. And if we did that properly, let's see what we get. So we can make this positive, and then, oops, sorry, and make it negative. All right, there we are. And then we subtract 2060, 2060, and we get the answer of $37.40. So 3740. Okay, so that is the, sorry, the future value was here. I should separate this, I guess, or maybe just put in here future value minus the total deposited. Yes, I got a little bit carried away there. So that is the future value here, and then this is the total deposited over here. And so there we are. It's just following through with it, and so this should be the answer, $37.40. Let's come down here and let's put that number in, $37.40, and see if it's correct. And it seems as though we are correct, yes. Okay, so there we are. We have to identify what values go where, and then we can do the question. And of course, the part is that you have to find the total deposited to get the how much interest was earned. Okay, so this was the amount that was deposited, and there is the future value right here. So then we subtract this number over here, and we get the answer for the interest earned. Okay, that is that question. All right, let's go to the next question. Let's see what's there. Well, this one, suppose you invest $170 at the end of every month for 3 years into an account earning 8% compounded monthly. Right? You're making monthly deposits. You're depositing monthly, yes, because at the end of every month. And then the compounding is also monthly. All right, so after 3 years, you leave the money. After 3 years, right here, you leave the money without making additional deposits for another 16 years, earning interest at 8% compounded monthly. All right, so answer the following questions. Answer the following questions and round all answers to 2 decimal places if necessary, right? How much will you have in the account after 3 years? Okay, so we're having a look at it, and then we can put in our values and see what comes out of it. Okay, so let's copy it and let's paste it in here. Okay, so this one is 4 question number 4, I think it is number 5. Number 5, yes. There was number 4, so now we have number 5. Okay, so there we are, and we have a little bit of a problem here, I guess. So let's see which one that's not the one we will decide to delete. Okay, let's delete that. And that should be 3 years, not 33 years, and this here is just 1/8%. Here is again 3 years. And down here we have 16 years. This is 8%. Okay, so there we are. All right, so the first part, you invest $170, that would be payment, right? So PMT is equal to, let's put it in as negative because money is going out, correct? Yes. All right, so let's put that in as negative 170. And then at the end of every 3 months, so that gives us the information for PY. So PY is equal to 4 end of every 3 months. And of course, end also plays an important role. That is why it's in bold. Okay, so payments are 4 times per year or every month. So it's 12. Sorry about that, every month. Okay, for 3 years. Now, you know, the 3 years, we will use that when we go to calculate N. All right? And it's an account earning 8%. So 8%, that means that is the IY value of 8. It's compounded monthly. So therefore, the CY will also be, get those there. Okay, so CY would be equal to 12. All right, so there we are. Okay, and after 3 years, you leave the money without making additional deposits. So that is important. That means what? Well, that means at that point in time, let's use a different color, maybe. That means at that point in time, the payment is equal to 0. Okay, that is after the 3 years for another 16 years. All right, so now it's 16 more years, and we keep going. Oh, PMT, sorry, there PMT is 0. And the interest is still 8% and it's compounded monthly. So this remains the same, right? So that remains the same. So the 8% and it's compounded monthly. So it's the same thing that this CY here would still be equal to 12. All right, so that just about sums up what information is provided. And we just need to go and do the computation. All right, so the PMT is negative 170, CY is 12, CY is 12, IY is 8, and we can go and insert those numbers, right? Yes, into the calculator and come up with the value. All right, so this breaks it down nicely, but then we can go back to the question over here and then fill in these boxes. That's its month. CY is 12. If you wish, you could also grab this and maybe pull it over here so we can see what is happening. Then we can maybe get more balance here. We do that, yeah, there we go. So we can see that CY is 12 and then CY is also 12 right over there. The value for N, we'll use the calculator to calculate that. So IY is 8, so we'll put in the 8 in there. The present value is what? Well, there's nothing to start. So we'll put 0 in there. There is a payment. The payment is 170. Let's put it in as negative 170. And the future value is the value we will compute. All right, so let's get started. We pull up the calculator and we can do some work with it. All right, let's pull this out maybe so you can see better there. There we are. All right, so we go second IY and CY is 12. So we put in 12 and then we look for CY. CY is also 12. So that is everything is great. Now we can get out of here by, sorry, my calculator disappeared. I just clicked on the wrong part of the display or the screen. So I can just click on clear and then I will be out of there. Now n is dependent on the number of years. The end of number of years is 3. So we go 3 second n. And the answer is 36. So we have to enter it now. We go n and click on n and we get the answer 36. IY is 8. All right. So we have all the numbers we need. Did I enter? No, I don't know if I've entered the IY. Let's enter that number now. The present value is 0. Payment is 170. So 170 plus minus payment. And then we compute the future value. That future value works out to be 6,891.04. Okay, $6,891.04. So how much will be in the account after 19 years? Well, the 19 years is coming. Please don't be deceived or misled. There's 3 years, and after 3 years is another 16 years that comes up. So when they're saying how much is in the account after 19 years, it really refers from the very start. Okay, so this second part is 16 years, all right? Because it says without making additional deposits for another 16 years. Okay, so PY will remain the same at 12 and CY will also be 12. And the number of years will be, well, N, we will use the calculator to do it, but what it does is multiply 16 years by 12 and we'll get an answer, right? Eventually. Okay, IY is still 8. Okay, so yes, earning interest at 8% compounded monthly. So IY is still 8. Now the present value will be the amount from the previous calculation, the future value. So this number will go in here. All right, the payment is 0. Oops, sorry. It will be 0. And then now we can compute the future value right here. Okay, so let's go and let's do that. So we have the future value there, and we can take that future value and actually make it the present value for the following calculation. So we can just click on present value, and there the number goes in. I know we're carrying extra decimals, but that's okay. The calculator this one shouldn't disrupt our calculation. So PY and CY are the same. Still remains the same from the very beginning. So PY is 12 and CY is also 12. All right, now the number of compounding periods, we have to take the 16 years. Remember, it's not 19 years, we're taking 16. So we take the 16, then we go second n, and we get 192. 16 times 12 is 192. Okay, let's see. Oops, sorry, I'm getting some problems there. 192. All right, good. So that is the number. And we can go back now and we can delete 16 times 12. Right, that gave us 192. IY is the same, but we can still check. Oh, sorry, I didn't enter the value for N. So there we go, click on N, and the 192 goes in. So I can just recall the value for IY, press RCL and IY, and there it is still 8. And then we can recall the present value to make sure what we had was being entered. Now, if you don't like carrying all those decimals, then you're more certainly welcome to put in 6891.04. All right, so there is the present value, and this is on the present value. Now, payment has become 0. Remember, before it was 170, now it's 0, so you have to go 0 and click on payment. And then we go and we compute the future value, right? So we go to compute future value, and the future value is this number right here, 24,679.53, right up here. Okay, $24,679.53. Okay, so let's submit it, and all is well. All the answers correctly. So there is a question where you have an annuity first part. There you have a payment. That's what determines whether it is annuity or not. It's periodic payments, like we saw before. If we go back in here and we go to the very definition of what an annuity is. Okay, so series of equal payments at regular intervals. Yes, more or less, that is right. Sometimes you will come on later where maybe the final payment might not be the same as all the other payments. But anyway, that's for a later lesson. Okay, so that is what that part was. And then we get to the compound interest. Back to compound interest. When that payment is 0, then it is surely compound interest. All right, that will be it for this lecture, and we will continue next time we meet.